Okay, so let's go through the VJC example 14 of the function notes. Okay, first we have the function to be defined fg, right, to be defined as fx to be x squared minus 1. So this one is the equation of the curve, or what they call rule. Then this one x more or equal to 0. So this is the domain, meaning the x value. So when you draw the graph, you must restrict the domain. So from here all the way to here. So you can see, right, this is the domain 0. So when you sub in 0 inside the equation, that will give you what they call the range, which is the y coordinate. It's a very fanciful way of saying y coordinate, -1. Okay, so gx square root x plus 4, the rule again. Then after that, x is an element of positive real number. Means that I do not include 0. So it's above, it's strictly more than 0. Okay, the very first part, they say, show that the function fg exists. First part. Second part, define your fg. So how do I actually show that fg composite function exists? So there's a rule that we must follow. So first, you draw the 3 circle. So g must come first because fg, right? Always go from right to left. G come first, then f. So here is domain of g, meaning the x coordinate of g. When you sub in the x coordinate of g, right, you will get the y coordinate of g, meaning the range of g. Then after that, if you sub in the domain of f, which is the x coordinate of f, you will get the y coordinate of f, meaning the range of f. So as long as you look at the center, as long as you fulfill the range of g to be a subset of the domain of f, the composite function fg will exist. Okay, so let's determine this together. So first, I draw the graph of f. So you can see, is this curve. Then for g, right, you draw the curve is this. So the domain of g, so let's look at the domain of g first. So domain of g is actually equal to 0 all the way to infinity. So you can see from here all the way to here, right? Okay, what about the range of g? The range of g is 2 all the way to infinity. Because you start off from 0, then you go all the way to infinity. So that's the range of g. Okay, so now I already know what is my range of g already. Okay, now let's determine the domain of f. Domain of f is just the x coordinate. So it's 0 all the way to infinity. Of course, the range of f is equal to -1 all the way to infinity. So in order to determine the range, domain and range, right, you must always plot the curve using the GC. Okay, so now we go back to the thing. So range of g subset of domain of f. So range of g we know, is 2 infinity, 2 to infinity. Domain of f is 0 all the way to infinity. So you can see that the range of g is a subset of the domain of f. So hence the fg actually exists. Okay, what about the second part? Define your fg. Okay, define fg, you must give them the equation of fg and you must give them the domain of fg. So let's determine the rule first, or the domain, or the equation. Right? So first, fg. So you can write as such, f. So you replace the g with the so-called equation x plus 4 bracket. So next you just need to, because you know that fx, right, fx is equal to x squared minus 1. So you just need to replace all the x that you see, right, with x squared root x plus 4. Means you will get something like this: x plus 4 bracket square minus 1. So this will give you x plus 4 minus 1, which is equal to x plus 3. So this is the equation of fg, or what they call the rule. Of course, you must give them the domain as well. Okay, domain, right? How do I determine the domain of fg? Okay, so with this, I go back to the circle. So domain g give you the range of g. Domain f give you the range of f. So starting from here, domain of fg will give you the range of fg. So just by looking at this, right, we know that domain of fg is equal to the domain of g. So this is how you remember So domain of fg equal to domain of g. Or another way you can remember is this. You look at the last member, g and g, right? So this is how you can memorize. Okay, I give an example. Domain of example AB is equal to the domain of B. How do I know that? Because it's B here, the last member, right? Okay, I give another example. Domain of x, y will be equal to domain of y, because it's the last member. Okay, so based on this, right? I know that domain of fg is actually equal to the domain of g. So domain of g, we know x is an element of positive real number, or you can simply just put like that. So you can put x is an element of positive real number. So that's all. So this is the domain, this is the rule of fg. Okay, so that is the very first part. Okay, the second part is the range of the composite function fg. How do I actually do, right? Very simple. I teach you the second method. Second method is the more general method, because first method might not work. So I must use the second method. Okay, so first I go to the three circles. So the three circles will be this. For example, domain of g, which is 0 to infinity, will give you the range of g. Range of g is 2 to infinity as determined already. Okay, now I do not write the domain. I do not write the domain of f, because I already know, okay, the thing already fulfilled. Means that the range of g is a subset of domain of f. So what I want to do now, right? I want to put this 2 to infinity to be the domain of f now. So now my domain of f, right, I put to be 2 to infinity. So 2 to infinity, of course not including 2 because I put a round bracket. So I sub inside. So assuming let's just say I draw the curve. So this is the fx curve, right? So where is the 2 now? The 2 is actually right here. Infinity don't need to say that, it's all the way to the very right hand side, right? So I want to start from here. So what is the domain here? The domain or the x coordinate is 2, right? So how do I determine the y coordinate? You simply just submit now. So f x, right, is equal to x squared minus 1. So 2 square minus 1, right, is equal to 3. Means that here is 3. The infinity is all the way here. Okay, so my range of f we know is from 3 all the way to the infinity. So this is 3 all the way to infinity. So this will be the range of f. And using this method, right, I can safely conclude, okay, my range of f, which is 3 to infinity, right, will be equal to the range of fg. So that is how we actually determine the range of fg. So range of fg, right, is from 3 to infinity. Yeah, so that is how we do this question.